Solving equations. Solving equations basically means isolating the x. Now there's some possible first steps we might want to do. These are all, I call these cleaning up steps. One thing you can do is combine like terms on each side of the equal sign of an equation. Another thing you can do, if you see parentheses, you may want to distribute. And all this is just trying to make the problem as short as possible, as soon as possible. And the way we're going to solve equations is we're going to add and subtract all variable terms to one side of the equal sign, and we're going to add and subtract all other terms to the other side, which will give us more like terms to combine, and then we can finish the problem by isolating the variable by dividing. So let's do a few examples. Let's look at 5x plus 3 equals 12. I'm actually going to change this problem to 5x minus 3 equals 12, so we won't have any fraction answers. So now it's 5x minus 3 equals 12. Now, if you're not for sure about how to solve equations, here's the basic idea of what's going on. What you're going to do is, or how you can think about it is, it's like a teeter-totter. On one side we have 5x minus 3, and on the other side we have a 12. And so, the whole goal is to end up with an x on one side of the equals. And as you can tell, we have an x term, and we have a term that doesn't have an x. Now our first goal is to get the x all by itself, or the x term all by itself. So what that means is, this minus 3 is in the way. So in order to get rid of that minus 3, we want to think opposites. I always think opposites. What's the opposite of subtracting? You would say addition. And so we're going to add 3 to eliminate the 3. Now when you do that, here's what happens. The teeter-totter is no longer balanced, because it has 3 more pounds over here. So to make it balanced again, without changing this side, we're going to come over here and we're going to add 3 more pounds. So what happens when you do that, it is now balanced once again. And as you can also tell, we have like terms on both sides. Minus 3 plus 3 is 0, and 5x remains, and 12 plus 3 is 15. Now, 5x plus 0 is 5x. Right side remains 15 still. Now our final goal that we want to end up with is an x all by itself. And as you can tell, we don't have an x all by itself. It's got a 5 in front. And that, when you read that, it's 5 times x. So how do you eliminate multiplication? Because we're always thinking opposites or undoing or inverses. What undoes multiplication? You would think division. So we're going to divide this side by a number that eliminates that 5, which is itself, because 5 divided by 5 cancels out and leaves a 1. But you must remember this. Well, what you do to one side of the teeter-totter, you gotta do to the other to keep it balanced. So if we divide one side by 5, we gotta divide the other side by 5. What happens is, you end up with the 1 times the next, which is the same thing as x. And over here we have 15 divided by 5, which is 3. And so, what we're saying is, for these two sides to be equal, x has to be 3. Let's check it. 5 times 3 is 15, and 15 minus 3 is 12. It does check out. Now you need to understand some of these steps. We're trying to get the x term isolated, because that's our first go. Isolate x terms. And our second go, as we do this process, is to isolate x. Now x could be a y, w, any variable. I just use x because it occurs most often in math class. So when you isolate the x term, we're eliminating this minus 3 by doing its opposite, because we want to end up with a 0. Because 0 plus anything is that same thing. And to get the x by itself, we're trying to make the number in front of the x become a 1, so we divide by itself, because 5 divided by 5 is 1, and 1 times anything is that anything, in this case, x. So that's kind of the idea of what's going on. And we're always thinking, well, what should you do to one side? 2 to the other. That's what you're always thinking. Never ever forget that. So now let's do these next few problems, and we're trying the minimum number of steps. Look at this one. We have 45 equals negative 10 minus x. We want the x by itself. To get the x by itself, we have to get rid of that minus 10. Think opposites. What's the opposite of a negative 10? You would say plus 10. So when I add it to this side of the equal sign, because there's the equal sign, I need to come over here and do the exact same thing because it's like a teeter totter. I'm trying to keep it balanced at all times. Negative 10 plus 10 gives us 0, which leaves negative x. Here on this side, left side, you have 45 plus 10, which is 55. So you have 55 equals a negative x. Now some people need to think of that negative x as a negative 1x. And I highly recommend it, because we now need to get rid of that negative 1 that's being multiplied by the x. How do you eliminate multiplication? Division. What you divide by what you see in front of the x, and negative 1. If you just use a plain old 1, you're going to end up with negative 1 over 1, which is a negative 1. And negative 1 times x is a negative x. We don't want that. We want a positive x. So if you use a negative divided by a negative is a positive, and it leaves the x. Because negative 1 divided by negative 1 is a positive 1x, and positive 1x is the same as x. 55 divided by the negative 1 is negative 55. To the next one. You want to get the x's on the same side, because the goal is x is on one, numbers on the other. Some people want to take that 7x over there, and if you take it over there, then you have everything on one side. We don't want that. We want x's on one, numbers on the other. We want the like terms on the same side, and the other like terms, in this case the constants, on the other. See these x's? They only want to be together and away from the number that doesn't have the x. So everything should be telling you that 3x has to go over there. It does two things. It isolates the 8, and it puts the x's on the same side. So when you see that, that's a plus 3x, positive 3x. What's the opposite of positive 3x? Negative, or subtracting. What you do to one side of the equals, do the other. These will cancel out because it gives us a 0, and 0 plus 8 is 8, and 7x minus 3x is 4x. Now we're back to isolating the x, and that's 4 times x, and what's the opposite of multiplying? Dividing. Those are cancel because it leaves a 1, and 1 times x is x. 8 divided by 4 is 2, and we're done. Let's look at this one. Anytime you got like terms that was already mentioned on either side, go ahead and combine them. The left side doesn't have any like terms. One has the next one doesn't. Right side, 8 plus 5, it's always 13. Now we want to get the x term by itself, which means we need to get that minus 9 out of the way, so we're going to do the opposite, add 9 to both sides. Leaves us with 2x equals 22, and then we're going to isolate the x by dividing by 2. Those cancel because it leaves a 1, and 1 times x is x. 22 divided by 2 is 11. Now look at this next problem. Parentheses. See, by the order of operations, you want to do what's inside, but you can't. They're not like terms. So the only other thing we can use to eliminate those parentheses is the de Sitter property, which just means we're going to take 6 times a, which is 6a, and 6 times negative 5, which is negative 30. So we've eliminated the parentheses. Next thing we're going to do is put the a's on the same side because we need those together. So don't move this one over there. We don't want everything on one side. We want the a's on one side and numbers on the other. So that's 6 a's in the wrong place. It needs to go over there, which means we need to get rid of it from this side. And that's a positive 6a, so we're going to subtract 6a from both sides. I don't do it to each term, I do it to each side. Once I do it over here, to this side of the equals, I've done it to the whole side. Keep that in mind. Now, when those cancel out, you probably want to cancel out here because 6a minus 6a is 0. 0, and when you cover it up, you see a negative 30 is left over. Don't forget that sign. And 4a minus 6a is negative 2a. 4 minus 6 is negative 2. And now we want to isolate the a, so we need to get rid of the negative 2 is being multiplied, so we use division. Whatever you see in front of the a is what you divide by. I see a negative 2. So we're going to divide by. And a negative 30 divided by a negative 2 is a negative. Nope, not a negative. Don't make the mistake. A negative divided by negative is a positive 15. See how easy it is to make a sign mistake? Now let's look at this example. Same thing. We're going to distribute the 4. Take 4 times x and you get 4x. 4 times 3 and you get 12. Bring down the right side. We want to isolate this x term by eliminating this 12. So we're going to subtract 12 from both sides. You're going to get 4x over here. Now notice 12 minus 12 is a 0. You're not done. We're trying to get x by itself. So what that means is we will need to get rid of that 4 that's being multiplied by dividing. And 0 divided by 4 is 0. The more of these that you do, you'll just start doing the steps without even thinking about it. Now let's solve one more type of problem. Just give you an idea of what to expect. 4x plus 8 equals 2x minus 10. Now when you look at that, you'll notice there's x terms on both sides and constants on both sides. And remember, the goal is to get x's on one side, numbers on the other. Now I always work with the variables first, the variable terms first. And a good reminder or a good process or good whatever to use is to always eliminate the smaller term, smaller coefficient. So in this case, I'm going to eliminate the 2x first. And that is a positive 2x. We're going to do subtract 2x. Watch do to one side, do the other. Notice, I don't do it to each term. I do it to each side. Once I do it to 2x over here, I've done it to the whole side. Once I subtract 2x from over here, from the 4x, is from the whole side. So now we have like terms. 4x minus 2x is 2x. We're going to drop the plus 8. 2x minus 2x is 0, and it leaves negative 10. Now I don't have a choice. To isolate this term, I have to eliminate that plus 8 by subtracting. Those become 0, which leaves a 2x. And negative 10 minus 8 is negative 18. And to isolate the x, which is our last goal, we have to get rid of the 2 being multiplied, and we do that by division, which do to one side, to the other. 2 over 2 is a 1, 1 times x is x. Negative 8 divided by 2 is negative 9, and we're done.